Hey everybody, what we're looking at right now is our next section of the topic 11 notes. And I want to start off with just a review of a whole bunch of different parts of the circle. Okay, I think originally when these notes were created, this was one of the first things that we looked at after spring break. So we've got a little review of some of our vocabulary terms and some of our formulas, the parts of a circle in particular. We've got a review of some of that stuff before we get into the actual new part of these notes right here. Okay, so we're going to go through these a little bit fast, but hopefully not too bad. We're going to start off by looking at the parts of a circle right here. And what I'm looking at specifically is in between point B and C. Okay, this distance around the edge of the circle right here, that would be called a minor arc. Okay, we know that an arc is a piece of the circle, and what makes this a minor arc is that this angle here on the inside, less than 180 degrees. Okay, it is less than half of a circle. Okay, that angle on the inside is less than half of a full rotation, so that would make this piece of the circle a minor arc. On the other hand, this part on the outside over here, that would be a major arc, because you can see that this represents more than half of the circle. That means the central angle going from right here around to right there, that central angle would be greater than 180 degrees. Okay? So the next thing inside of this circle is the little line segment in between point A and point C. That is a radius. Okay, so it's a line segment where one of the end of it is on the circle, the other end is the center of the circle. Okay, it goes halfway across the middle of the circle. That's a radius. All right. So moving now down to this one, you can see up on top right here, you've got a semicircle. Okay, a semicircle means half of a circle, and that's actually what we're comparing these major and minor arcs to. Okay, major arc is more than a semicircle, minor arc is less than a semicircle. Okay, so that means on a semicircle, this central angle right here, going from here, rotating around just right there, just that little area right there, would be exactly 180 degrees, that central angle. And this line that cuts across and marks where a semicircle is, that line segment EG, that is a diameter. All right, so there we have that. Okay, up next we've got a bunch of formulas. Okay, this first one right here is kind of a formula, sort of kind of a formula, but what it really is, we know that pi is a constant. It is a number. This symbol right here represents the same number every time. It is approximately 3.14. But when we talk about it specifically with circles, we also know that it is a ratio comparing the circumference divided by diameter. Now, we're going to talk about this in an activity later on in the week. I just wanted to take note of this right here. It is about 3.14. It's a very long, very long, never ending decimal. But it also represents the relationship between the circumference and the diameter of a circle. Now, let's talk about the circumference. Okay, the circumference, the formula we've used a whole bunch of times is this one right here, 2 times pi times the radius. Or you could also use the one that you learned back in about 8th grade, which is pi times diameter. Okay, both of these are the same thing because we know that 2 times r, well, that is d. Okay, so those two formulas are really the same thing. Our other formula, the one that we're going to be using today, is area. The area of a circle is pi times the radius squared. Okay, pi times the radius squared. Our next thing, this is what we talked about in our previous lesson, the length of an arc. Okay, it all has to do with the central angle and it has to do with the radius of a circle. Okay, so if you're looking at the length of the arc, you're looking at the length of the crust of this slice of pizza that's right here. Okay, the distance from A to B going around the edge of that circle. The length of the arc is you take that central angle divided by 360, and then you take that fraction and multiply it times the area, or times the circumference, times the circumference, 2 times pi times r. Okay, and the idea here is that this fraction, okay, we know that this angle right here is a fraction out of 360, okay? This is only a little piece of a full rotation of 360 degrees. Well, this little piece of the rotation is the same amount as this little piece of the circumference. Okay, this one arc is only part of the whole entire way, all the way around the outside of the circle. So this fraction out of 360 is the same as this fraction out of the circumference. It's proportional. So that's why we can multiply those together and get the length of an arc. Our last set of formulas that we used was actually just a quick little conversion factor. If you are trying to convert a degree measurement of an angle into a radian measurement, you multiply times pi divided by 180. And if you're trying to convert the other way, going from radians to degrees, you multiply times 180 over pi. All right. So all of these things are going to come up as you look at your Canvas problems today. There's some review, but there's also going to be some new stuff, and that's what we're about to look at right here. This new stuff is the area of a sector. Okay, so first let's define what a sector is. Okay, it's written on your page. It's this right here. A sector of a circle is the region in between two radii. So if you draw a radius here and a radius here, it's all this area in between those two line segments and the arc. Okay, it is the area of a slice of pizza. So when we looked at arc length before, when we looked at arc length in one of our previous here it is. When we looked at arc length, we talked about how the length of an arc is the length of that piece of crust. Okay? We're not dealing with arc length anymore. We're dealing with the entire area of this whole entire piece of pizza, not just the part on the very outside of the circle. Okay? So it's very, very similar. You're going to find when we get to these problems, it's very similar to what we did when we found arc length. First, we start with finding the area of a circle. Okay, we already know that formula is pi times the radius squared. You may remember that we probably want to draw parentheses around that r squared just to ensure that that's the only thing that the exponent applies to. Okay, the area of the circle is pi times the radius squared. So the area of the sector is going to be just a fraction of that area. Okay, now we already know that one slice of pizza, I mean, that's just common sense. One slice of pizza is only a part of this whole entire thing, right? So if we can figure out what fraction it is, we can just divide, or we can take the area of the circle and multiply times that fraction, and that'll tell us how much this one little area would be. So the way we do that is we find a central angle fraction, just like we did before. Theta divided by 360, the central angle divided by 360, and then multiply that times pi r squared. We multiply that times the area. Okay, so we take the central angle fraction, multiply it times the area, just like we did before when you took that fraction and multiplied times the circumference. All right, so let's take a look at two example problems. We're going to have some steps to follow that you'll find are very similar to what we did last time. Step number one, we need to first find the area of the circle. Step number two, we need to find the central angle fraction. Step number three, multiply those numbers together. Okay, multiply the numbers from steps 1 and 2. All right, this is pretty simple stuff. So we'll start with this first problem right here. When we look at the area, the formula for that is pi times the radius squared. So we look at this circle and we ask ourselves, what is the radius? That would be this number right here, this 2. That would be the length from A and B. Okay, so we put that in. 2 squared is 4. So that's 4 pi. Now, I want to keep something in mind here. As you're working on your Canvas problems, you may notice that sometimes the answers are presented in terms of pi. Okay, we know in our heads and in our calculators that 4 pi is equal to 12.566, but keep in mind that you might need to keep it like this when you multiply. Okay, step number 2, let's talk about our central angle fraction. We've got 60 degrees, and we know that a full rotation is 360 degrees. So that's going to be our central angle fraction right there. That's step number 2, 60 over 360. So we take our area, multiply it times 60 over 360, Y'all, it's going to be helpful to you in this section also, starting right now, if you can look at these angles and reduce these fractions down. 60 out of 360, that's the same thing as 6 out of 36. If you know your multiplication tables from back in the day, you know that that is the same as 1 out of 6. Okay? So we're multiplying 4 pi times 1/6. That's going to be equal to about 2.1. Now I'm going to put this in a different way also. Okay? That's the same thing as 4 pi times 1/6, right? If we put that 4 pi over 1, that's the same thing as multiplying across the top gives us 4 pi. On top gives us 4 pi, and on bottom we've got 1 times 6. Well, this can reduce down. You can see 4 over 6 is the same as 2/3, so 4 pi over 6 would be 2 pi over 3. Okay, just something to keep in mind as you're working on your practice problems, that it might be presented in terms of fractions like this instead of like this. Okay, but worst case scenario, absolute worst case scenario, if you don't know what you're doing, go through the answer choices and see if your decimal answer matches any of these fraction answers. Okay, punch these fraction answers into the calculator and see what matches your decimal. All right, just a suggestion. Something to look into. Okay. Our second problem, our second example, find the area. So we take pi r squared. That's going to be pi times 5 squared, which is 25 pi. 25 pi, you can type in the calculator. It's about 78.54 when you round it up just a touch. Okay. Our sector area, excuse me. Step number 2, we got to find our fraction. Well, we look at our central angle here. Our central angle is 120 degrees. That's theta. So we're going to have 120 out of 360. You may be able to recognize pretty quick that that is going to reduce down also. Just like this one up here, this 120 out of 360 is going to reduce down to 1/3. Okay, so you might end up on a problem like this. This right here is the equivalent to 25 pi times 1/3. Okay, so you might end up, instead of getting a decimal answer by multiplying those two things, getting 26.2, you might end up with an answer like 25 pi over 3 instead. Okay, be on the lookout for something like that in your multiple choice questions. All right, so there's what we have there. So it's just, think about what this 1/3 represents also. Okay, when we look at this this slice of the circle, I mean, you can recognize that if this was a pizza, this would be a very large slice, right? This would be a great big old wide slice of pizza. But what it is if this angle is 120 degrees, that's 1/3 of a full rotation, right? So that means this piece of pizza is 1/3 out of the entire thing. Okay, this one slice is 1/3 of the entire pizza. That's why it seems like such a big thing. Okay, that's what this fraction represents. That's what this fraction represents. It means that this slice would be 1/6 of the entire thing. Okay, so keep that in mind as you're working. You're just taking however much one slice of that pizza would be. All right. So y'all get after those Canvas problems. Don't forget about them. Okay, they're all going to be due real soon, and that's one of the biggest things that affects your grade. Honestly, is the people that ignore these Canvas assignments are consistently getting the lowest overall grades. Okay, so get to work on it. Don't just blow this stuff off. Get some work done, and it'll help your grades, and it'll show how much effort you're putting into this. All right. That's all we've got for today. Y'all have a good one.